This is going to be really good. So we got to record this. Okay. Yeah, should we put some stripes on this lighthouse? You can put some brick, maybe some brickwork on there. Some rocky crags down below, maybe. Yeah, maybe some birds and some clouds. Yeah, do it. Add some detail, okay? Yeah, add some clouds up in the sky. Except maybe it's at night. I don't know. We'll add some water down below, and of course a buoy, right? And a buoy floating out here. Okay, blinking, alerting ships of danger. Okay. Okay. And we have to label some things too. Rocky crag here, okay. Now I'm going to destroy the picture. Okay, here we go. What is that supposed to be? 130 feet? How's that look? Close enough. All right. Okay, so now we don't care about the picture anymore. We just realized it's actually just a triangle. Okay. And if we look out on the horizontal, and then this is what we mean by angle of depression. And in the future problem here on, I think, number 3, we use the word angle of elevation, so you can find out what both of those mean right now. Angle of depression means you look out straight and then depress your eyes 6 degrees, right? So you're looking down 6 degrees, and then when you do that, you're like, a buoy in the water, look at that. So that's what that means. And if you look out horizontally like that, and then look up, we call that the angle of elevation. In another problem, we might be talking about that. So, but here we're looking out and then down 6 degrees. So that's what that means. And is that everything to be marked on the diagram has been marked? Okay. And then the thing we're looking for is this distance along the bottom of the triangle that I drew. And we need a name for that. And the name we're going to give that is, Emmanuel, give a letter for that. Pick your favorite letter. F for, why did you pick F?
Yeah,
for what?
I don't know why.
For, this is the thing we want to find.
Sure.
Okay? That's what that stands for. We do not know it, but we would like to find it. So that's why we're going to call it F. Okay? So then now, that was the hard part right there, drawing a picture. Write down trig ratio of some kind, write down something true about this situation, involving the angles, some statement that relates the angle to the sides, some statement that maybe can even help you figure out what F is. So do that on your own. I'm interested to see hear what all the different ratios and different things you write down are. There's not one answer here. In the end, there is one answer for F, but there are multiple ways you could write this down. 6 degrees. Already, I'm seeing lots of different things people are writing down. All of them are correct, though, so I just want to get a little survey. Give me something. What'd you write down? You want to share one, Chris? Tangent of 84 degrees. Now I don't have an 84 degrees in my picture here. Are you thinking about this angle here? I'm with you. Do you guys agree that that's 84 degrees? Okay, so that's what she's going for. And she says the tangent of 84 degrees is equal to F over 130 feet. You with her on that? And then it's like problem is done now. F equals, she says, 130 tan 84. And that is approximately equal to what she said. 1,236.8. Okay. 0.87 feet, or 3 sig figs, 1240 approximately. About 1,240 feet. So this is, by the way, not the scale. Okay, just so unless that wasn't already clear. This is definitely not 6 degrees. You know, various things that are problematic with this picture. But is that cool on that first problem? That felt good. What other maybe I won't write them down, but what other trig ratios did you set up out there? Because this is not the thing I saw everyone write down. People in the back, yeah, go ahead. Is that you raising your hand? Tan 6. Oh, okay, so you're thinking about this angle down here, which we haven't yet labeled, is 6 degrees. So tangent of 6 is equal to 130 over F. I think that'll get you the answer too if you solve that. Anyone else have a different one that wasn't said? You have a different one, Chad? Yeah, I think I like thinking about right triangle trig. We were going to teach you something called law of sines, which works for any triangle, not just right triangles. But the reason the law of sines even works is because of this technology. We're like the right triangle technology. So we'll think about that. But that is true. We do it different ways. Okay. Let's do the next problem. This time, here, you want to read it for us about an observer?
An observer on top of a 100-foot building watches the car approach the building. The person observes the angle of depression of the car changing from 22 degrees to 46 degrees. How far does the car travel?
Okay, so draw. All right, draw your picture here. For the sake of time, you can soup up your building in whatever way you like. You know, add some detail to your building in whatever way you like. Okay, add some doors, something. Okay, that's good. It's an important element of the problem. Draw, and now we're trying to figure out how far that car traveled. This is not two different cars. This is like two instances of the car, the same car, isn't it? So again, and then destroy your diagram by turning everything into points and dots and lines. Okay, here we go. Cool. 100 feet. Is that distance there? And 22 degrees is the angle of depression first. Is that, by the way, us seeing the car come toward the building if we're 22 degrees, and then the angle of depression is 46 degrees? That is the car coming closer, isn't it? Okay. Good. That's, I think, all the information from the problem you put onto the diagram, isn't it? Yeah.
So I'd like to second Katie's question. The building is 100 feet tall, but how tall is the person?
Yeah. So let's pretend that the person is like laying down at the edge of the building with their eye right on the edge of the building. Or that by 100 feet we really meant distance to the eye.
Got it.
Mathematical models and assumptions. Okay. Does it matter? I don't know. I would like to figure out what this distance is, I guess, is the question that's being asked. How far did the car travel? So what is that distance there? We need a name for it. Chris, help me out. Give me a letter, your favorite letter. Huh? X? For, what does that stand for? Means X marks the spot. It's like our traditional one. I don't know. We don't know. Actually, I would actually maybe even like to introduce another letter into the mix. Another distance that I might like to mark, at least just temporarily, until I figure out what's going on. You want to give me another distance you'd like to mark? There are a couple options for distances. We'll go with what you say, Piper. For which distance do you want to mark? The whole thing? You want to call P? Okay. The only reason I say that is because some of you out there who have already started working this problem, you might have chosen another distance to mark, and it might have been this distance from here to here, right? So whatever. I'm just saying you might need another name in the picture somehow. And what does P stand for? Okay. And maybe it means the path. Okay, good. Yeah, the path that the car is traveling, and that's like the total distance. Maybe Piper is the one driving the car. There you go. Okay. We just need to like lay some meaning into whatever choices we make in mathematics. Okay, so, all right, I'm fine as long as you can justify it. All right, here we go. Write down some stuff that is true. Write down some true statements that relate to the letters, the angles, the numbers, and see if even just the act of doing that mindlessly maybe even helps you solve the problem. I don't know. By the way, don't let me discourage if you solved it a different way, if you label it a different way, if you whatever, do it your way. You know. Should hopefully not make it. Everyone actually is using PNX. That's good. They're not required. Okay, I'm a little stuck on this problem, but someone give me any true statement that you've got so far, even if you're not done. Any kind of relationship, again, maybe involving a trig function of some kind. I don't know. What you got? Michelle, is that you? Do you have one? Have anything written down? Yeah, this one here, is that what you're looking at? It is 44. I think I agree with that. 44. That is good. I mean, you may, by the way, yeah, you may want to label some other angles in this picture if that helps. This is 22. And this is 46. Gabe, you decided to share. Go. Give me a ratio.
Larger angle, which is 68.
And 68 is this big guy here. Is that what you're saying? If you want it. Yeah, we have two triangles in this picture, which is that's a little bit hard to keep track of, but we have them all labeled nicely. I don't have a trig ratio. I'm still looking for any true statement involving the letters and possibly trig function. Okay, Sean. All right, I'm going to write it down, and then I'm going to figure out whether that's what I like or not. 68. Tangent of 68 is definitely P over 100. Yeah. So in a second, we're going to know what P is, right? Like you could actually tell me now. Isn't P 110 68? That's nice. So we actually have no more P. We have no more P. Sorry. Your letters go. Okay, next. Give me another thing that involves maybe X, because that's of course what we want to say something about too. Just so we have a name for this other side length. Do you need this other side length in your life? I think it's of length P minus X, isn't it? Do you agree? Give me another ratio. Some of you obviously have it. You're like, I'm like, already done with the problem. Give me another ratio. Another statement.
Okay, so I did P minus X, so
Okay.
tan 44 equals P minus X over 100.
Tan 44 is equal to P minus x over 100. Let's just step away, make sure she's right on that. P minus x over 100 is the tangent of this angle 44 degrees there. I think I agree. So yeah, I think I have a full view of what's going to happen here. We got P minus x equals 100 tan 44. Keep in mind that we have P. So what's x? Well, it'll be P minus this. So I mean, just plug stuff in and solve. And again, this is not the only road to a solution. Many of you also used, took the tangents of these angles down here, and you would have gotten the answer too. All right, so in a second, we're going to write down the answer. The answer is 151 feet. I just checked my answer key. Okay. And by that I mean Grant. Okay. I'm doing 3 sig figs just like as a model because it doesn't say one way or another, but yeah, unless it specifies, we can do 3 sig figs. Okay. Can we do the Spider-Man problem? Yeah, let's do the Spider-Man problem. Read for us, if you will, Elena. Where are you these days now? Move people around. The Spider-Man problem? Where's Lena? Is that why I can't find her in this room right now?
Mr. Chase, who can notice that angle from 200 feet away?
They're using a clinometer. Yeah. Michelle gets to read this one. Go ahead. Spider-Man. You know it's going to be good if the first word is Spider-Man.
Spider-Man is crawling up the side of the building. An observer 200 feet away from the bottom of the building records Spider-Man as having a 30-degree elevation and 23 seconds later having a 40-degree elevation. What is Spider-Man's average velocity during this time?
All right, there we go. We got an observer watching Spider-Man crawl up the side of the building.
Sell this.
It's his biggest fan. Here's Spider-Man. Okay. And Mary Jane, maybe, yeah. Again, feel free to add more detail to the building. Draw your Spider-Man in whatever nice way you like. Okay. The pictures are the fun part here, aren't they? Okay. "200 feet away" is this bottom piece.
Yeah.
And here we're talking about angle of elevation, so from 30 to 40 degrees, right? So 30 degrees and then 40 degrees. That does represent an increase in height, I think, for Spider-Man, so that's good. So then the question is, how far did he travel during that time? Maybe before we even ask the actual question, which is what is his average velocity, what is his distance that he traveled? That would be an interesting question to ask. Wouldn't it be an interesting question to ask? Would you like to name a variable for that, Maria? You seem excited about this. What label would you like to give for that right there? I like that. I like that. And again, you might want to introduce another letter in your life as well. Whatever letter that might be. H for height. And you could call this the height there. I don't know. Whatever. I think this actually feels similar to the last problem, doesn't it? Just kind of like sideways. It is actually kind of similar, isn't it? So work it out. I think maybe we won't go through the details of this one, but we'll tell everyone what the answer is in a minute here. Give me D, and then also that's not the end of the problem. Remember, see if we also get setup and trig ratios. So if we can figure out how far he went, then I think we. Oh yeah, sure. We'll assume that that's true for the problem. Or you can say maybe. We haven't had a mature conversation about that yet.
Chase,
Yeah, what's up?
is Angela's son in class?
Yeah. What?
I'll ask her to go to attendance for just a moment.
Okay. All right. We'll do whatever you say.
Fire.
It's been real. So when you get the answer, let us know. We'll put it up here and people can work it out. I don't want to. It really does feel like the last one I would think, right? What it kind of feels like two triangles. I found a friend of mine. She says 52.3 feet. So see if you get that answer too. Did you get that? People out there. Yeah. 4-5 tonight. 52.4. 52.3. It's closer to 52.3. But that's of course not the answer then too. Make sure you actually answer what was asked. We're supposed to find like the speed or the velocity. So in 23 seconds, so we get some answer in feet per second then. 2.28 says. You agree? Okay, so that's our final answer. Again, I intentionally omitted the work here. Hopefully, someone at the table can help you out. It should feel very similar to the last problem. And many roads lead to this answer, right? There are a couple different ways to set it up. There are two triangles. Huh? It is, but it didn't actually say that anyone's like chasing him or anything. He might just be out for like a recreational climb on the wall. Yeah, a leisure climb, He may just be like coming back from groceries and he's like headed to his apartment, you want to get on it.
I mean, those groceries don't be slowing down.
There you go.
He's a one-trip kind of guy.
He's a one-trip, yeah, he probably is.
Just blows it all up.
All right, so the other thing that I promised that we'd mention today is the law of sines. So we'll do that with the remaining time. We'll talk a little bit about the law of sines.
Can we take notes on this?
I'm gonna, you can put notes on the back or your notebook, however you do. Okay. I hesitate to just like throw it up here, right there. There it is. It sounds like some of you are acquainted with the law of sines. Is this part of? I think this is something you do in geometry, maybe at one point. At one point in your life, you've maybe thought about the law of sines. So here it is again. But if you haven't done so, I would challenge you to prove it as well. It's actually not too hard to prove with this picture, right? So draw yourself an arbitrary triangle, and then drop a height in it. That is an altitude perpendicular to the base. That will divide your picture into two right triangles, won't it? Correct. Yes, I'm right. Okay. And then think about how you might express h in two different ways in this picture, right? There may be two different ways of thinking about what h is, depending on which right triangle you're looking at. And see if you can't at least establish the first equal sign in this equality up top. That sine of a over a is equal sine of b over b. And sorry, we haven't said it yet. This is kind of tradition in geometry to use the capital letters to name the angles, and the lowercase letters of the same type to name the opposite sides, right? So little a is the side opposite angle big A, right? Etc. So anyway, try doing this proof on your own if you like. You can ask if you need some guidance, or you can look in the book. But it should probably take you, I don't know, I think you probably get it inside 10 minutes.
The exercise for history class.
Or chemistry or something. I'm equal opportunity. Around the dinner table with your family. Lots of options here. Don't laugh. Some of you would do that around your family. You never proved something around the dinner table? I just feel that's like a missing element of your life. I prove things around my dinner table. You should do the same thing. All right. So there it is. There's, the reason I kind of say this for last is because really it is kind of mechanical. There's not a rich discussion to have around this yet. Tomorrow we have, excuse me, Monday, we will have a lot more to say about it. But the kind of problems I'm going to throw at you are ones like this. I give you like A's, B's, and C's, and you find like the other things by using this equation. Like there's not, I don't have like a super creative problem to throw at you today, really. Wait. Did you ever figure out the last problem? Those who are still finishing, did you get 52.3 feet and then 2.28 feet per second? Hopefully, I didn't mean to cut you off there, but go back and, but no, but it's okay. I'm sure you'll revisit in you know, your AP basket weaving class later today. You can do that. You can work it out. Your IB gardening class. I don't know. Whatever.
I wish that was something. HL in that so hard.
HL Kazoo.
Life skills.
No, I'm actually doing
HL
HL.
Slam, please.
No,
Oh, no, I know that.
I don't mean to interrupt this inspiring conversation. But let's actually try this. Again, I don't have a lot to say here. This is what we mean by, maybe I do need to remind you, I think we've done this a couple times already, but by solve a triangle, we always mean like, I give you some stuff, please give me the stuff I didn't give you, right? Like, so here I've given you angle Q, angle R, and side Q. So I need you to find me side R and side S, and angle S, right? So, and by the way, again, this is the law of sines we just talked about. This is a rule for any triangle, not just right triangles. And this is not a right triangle, and it's not obvious. So what is the, what's the first thing you're getting right now? Yeah, angle S is kind of low-hanging fruit, isn't it? We can know that in just seconds from now. We don't need the law of sines for that, do we? What does that come out to? 96 degrees? So in fact, it's not just, it's not a right triangle, that's for sure. And it's also not a obtuse triangle. That's interesting, by a hair. Okay. No big deal though, we'll move on here. So how do we find, what's the next thing we want? How about like little r? How do we find little r? What's an equation you can write down if you do indeed know the law of sines? Piper wants it.
Sine 36 over 8
Oh, you're finding a little r? That's fine. Yeah, whatever. Yeah. Is that what I said? Little s? Okay, whatever. Yeah, okay. So, yeah, that's good. Sorry, I didn't know what I was talking about. You're doing good. Let's just keep going. Okay, that's good. Okay. So solve that for r. Set up a similar equation to find little s. I really don't have much commentary on this. If you could. I sound so disappointed in the problem. Well, it's my fault for giving you a not very interesting problem, maybe. We will need a calculator to help us on these here. So r will be, what, 8 sine 48 over sine 36. You do a little switcheroo there. R will be 8 sine 48 over sine 36.
Me too.
Did you get 10.1?
Yeah.
If Katie says yes, then we're good. 10.1 with no units, I guess. So whatever, we'll leave it there. And then similar work will get us. Will get us S. What'd you get? 13.5? Someone confirm that? Yeah? Good. I have another one, but I don't know. It's really not. Is it really interesting? Let me see. Let me decide whether it's interesting or not. Not really. Not really. Well, it is. I guess it's interesting in one respect, like that you know the sign of 60 and 45. So that makes it interesting. Huh? You want to do a blue card?